Chapter 11, Lesson 2, Simplify Radical Expressions. We've already talked about this quite a bit, and some of the stuff was from last year, but just this is a sort of reminder of how to simplify radical expressions to make them so they're in their simplest form. Just a reminder, their simplest form means that the thing underneath, the number underneath the radical cannot be simplified by pulling out any extra parts of it to being outside the radical. What I mean by that is this, it says here, 36 is just 6 and 6. Square root of 36 is 6 and 6. And remember how we talked about how they can go outside and play. So this is just 6. You probably just know that right off the hand. The square root of 36 is 6. But a couple of different ways of doing this. This is the same as the square root of 2 times the square root of 36. And so that makes sense that it's square root of 2, or 6 times the square root of 2. Another way of doing this, 36 and 2. Then you end up with the same thing here. These two can go outside. The 2 has to stand by itself. So let's look quickly here. Here we've got 48 and x. And then we've got 4 and 12. Then we got 2 and 2. Those are simplest forms, so is that. We've got 4 and 3. That's prime factorized. So what we have here is we have these ones can go outside, these ones can go outside, and the 3 and the x cannot. So let's start with the 3 and the x. And then we have one pair that can go outside, that's 2's, and one pair that can go outside, there's 2's again. What's 2 times 2? That's 4. And that makes sense because 16 times 3 is going to be 48. And that's going to be times x. So that's, again, double checking there. This one here, same sort of idea here. X and x. So these two can go outside. Just going to put them there. And then we have to simplify this. We're going to do this 16 and 2. And 4 and 4. That's simplified, and then whenever you get to a point where you have two numbers that are matching, you can just take them outside like that. So this is going to be that. So that was just a brief refresher. Now let's look at the more complicated stuff here. Traditionally, we don't like to have radicals and denominators. That's just a rule. You can't go ahead and have it that way. So if you have an expression like this, the way that you get rid of the radical on the bottom is to multiply by the exact same radical. When you do that, you end up with a square root times a square root. So square root of 2 times the square root of 2 is just going to be equal to 2, right? Square root of 15x times the square root of 15x is just going to be equal to 15x. Same sort of idea here. But we're then basically moving this part here, the radical 6x, we're moving that to the top, and then we're changing the bottom so it's an actual full number. And then you're simplifying afterwards like they did here, the 3 and the 2, that can simplify to 1 over 2. This is equal to 1. Remember, you can always multiply it by 1. So let's look at it. We're going to rationalize these denominators. And this is actually pretty straightforward. All it is you're going to multiply by the same thing. Multiply the same thing on the top and the bottom. So that's just by 1. So this is going to be 3 radical 2x. That's all going to be over 2x. And you're done. Here, a little bit more complicated. Not really, actually, but radical 10. But we're going to have to simplify afterwards. So this is going to be 5 radical 10. This is just going to be 10. 5 goes into 10, so it's going to be 1, which we don't need to have, so it's just going to be radical 10. If you want, remember the 1 is out there if you want to do that. But so this is just going to be 10 radical 10 over 2. These ones here, same sort of idea here. If you can simplify them, then you can simplify them and then add. The important thing is recognize which ones are as simple as they can get. These ones here are all as simple as they can get. actually, so is this one here, so is this one here. But this one here can be simplified, so can this one here. And then if we simplify them and then are able to add them, that's an important skill. So let's look at this here. I'm going to look at this red piece here. So 6 radical 27, what's that simplified? That's going to be, I'm not going to worry about the 6, I'm going to just worry about the radical 27 right now. 3 and 9, and then that's there, and then 3 and 3. So these are all, so this can go outside. So what's 3 times 6? That's 18. I'm bringing the 6 back in there. And then what stays underneath? That's the 3. So I now change this expression here to the following. 3, radical 3, and then it's plus 18 radical 3. So now it's just going to be 21 radical 3. So that's how you do these sort of problems. You just work on them that way. For this one here, we're just looking for where we can combine things because they're all simplified as much as they can be. 6 minus 3, because I have both radical 7s there. It's just like if it was like a 6x and 3x. What's 6 minus 3? It's going to be 3. So it's going to be 3 radical 7 plus 8 radical 10. This one here is a little bit more complicated, but again, it's the same rule here. I'm going to go ahead and figure out what 2 radical 500 is going to be. And I'm going to do this the simplest way for me. That's simplified, and that's just 10 and 10. And once I get to that point, I realize that I got a pair of numbers here I can pull out. So 10, pull that out, times the 2, it's going to be 20. It's going to be times radical. I still have that 5 to deal with. So this is going to be now 3 radical 5 plus 20 radical 5, which is equal to 23 radical 5. Now, these ones here are, you have to use something called a conjugate, because at the bottom here, if it was just radical 3, we could multiply by radical 3 on the bottom and radical 3 on the top. But we have to use kind of our factoring skills or our FOIL skills, because what we want to do is we want to get rid of the middle expression. The way you get rid of the middle expression is by multiplying by the same thing, except for it's a subtraction problem in the middle, or an addition problem, depending upon which way it is. If you remember when we talked about this before, it's x, remember x plus 1 is x minus 1. It's going to be equal to x squared minus 2, or minus 2, sorry about that. X squared minus 1. That gets rid of the middle expression because you have a plus, if I wanted to write this out full and all the way, it would be x squared plus 1x minus 1x minus 1. These cancel each other out, so you're just left with x squared minus 1. So that's really important to understand, because when we're using conjugates, all we're going to do is the exact same method. Here I'm going to multiply by 2 minus. Remember, I have to do this on the top as well. When I do that, what I'm going to end up on the top is what's 4 times 2? That's 8 minus 4 times radical 3. Now on the bottom, I'm going to end up with 4, because 2 times 2 is 4, and minus 3, because radical 3 times radical 3 is going to be 3, and then I have its subtraction. So just like I did before, so if this is 8 minus 4 radical 3 all over 1. So it's actually just going to be 8 minus 4 radical 3 is the simplest way of doing this. Same thing here, except for now I'm going to multiply by radical 7 minus 1, radical 7 minus 1. And here I end up with 2 radical 7 2 radical 7 minus 2. That's all over 7 minus 1. You're always going to end up with that minus You're always going to end up with whole numbers on the bottom. If you do it the right way, 2 radical 7 minus 2, all going to be over 6. And then I can simplify this because 2 goes into all 3 of the things here. It goes into the 2 goes into this, 2 goes into this, and 2 goes into this. So I can divide everything by 2, and I end up with radical 7 minus 1 over 3. And that's my simplified form.